So the last video, I hope it gave you a sort of introduction to the application of the chain rule. We're going to do even more examples in this video, and hopefully it'll show you a wider variety of applications and really firm up your knowledge of the chain rule. All of these problems are going to be solved using the faster derivative of the inside, derivative of the outside method of the chain rule, so we're not going to go back to the g of x and f of x definitions. Alright, let's start with this one. Find the derivative with respect to x of the natural log of the quantity 1 minus 12 over x, and we're going to restrict the domain to x greater than 12. The reason we do that is because if you put numbers x less than 12 in here, then you end up with a negative number inside the natural log, and the natural log of negative or non-positive numbers is undefined. So we got this function only exists where x is greater than 12. Okay, let's go about doing this. Natural log, well, the derivative of the natural log, let's recopy the problem, dx of the natural log of the quantity 1 minus 12 over x is going to be, alright, first we take the derivative of the outer function, in other words the natural log part of the function, and the derivative of a natural log is just 1 over x. So what we're going to do is, that's the outer function, and so the derivative of that is going to be 1 over the inner function, which is 1 minus 12 over x. Okay, so that's the derivative of the outer function. The derivative of the inner function is going to be, let's underline this in green. Okay, so that's the inner function, 1 minus 12 over x. That's going to be the same thing as negative 12. Actually, no, it's not going to be negative 12. Well, negative 12 times the quantity negative 1 times x to the negative second power. Okay, that's just a power rule application of applied to 1 over x, which is the same thing as x to the negative first power. Alright, let's clean this up a little bit. Let's see, the two negatives in here in the green part cancel out, and so let's switch back to blue ink. This derivative is going to be equal to 12 over x squared times 1 minus 12 over x. Okay, let's see, we can probably find a common denominator here. This, honestly, stopping right here would be an okay answer. But compound fractions, fractions within a fraction, tend to be a little confusing, so finding a common denominator and then eliminating the compound fraction would help to clarify things. So if we want to do a really thorough job of this, we're going to go 12 over x squared times the quantity x minus 12 over x, and the x squared and the x on the bottom cancel each other out, and so what you end up with is going to be 12 over x times x minus 12. Okay, so if you wanted, you could leave it at this stage, or you could multiply the x through, and so this would be 12 over x squared minus 12. Okay, any of these three answers are okay. The last two are really the better answers. Alright, so I of q is equal to e to the cosine q. Find the slope of the tangent at q equals negative pi radians. Alrighty. So, just a reminder, slope of the tangent is the same thing as the derivative. So really what this is saying is find the derivative at q equals negative pi. So the first thing we have to do is find the derivative. So step one of solving this problem is going to be to find the derivative as a function of q, and then so find I prime of q, otherwise known as di dq, and step two is then going to be to substitute q equals negative pi radians. And remember, radians is just a unit. Into the expression for I prime or di dq. Alright, so first taking the derivative is not too bad. We have our inner function, which is cosine q, and then we have our outer function, which is e. So the derivative di dq is going to be the derivative of the outer function. So derivative of e to the x is e to the x. Similarly, derivative of e to the cosine q is derivative of is e to the cosine q. So part one of this is going to be e to the cosine q. That's a derivative of the outer function, leaving the inner function alone. And now we're going to take the derivative of the inner function. So derivative of the inner function is cosine q. Derivative of cosine q is negative sine of q. Okay, and then just clean this up a little bit. I'm not sure how much real cleaning up you can do. This is going to be negative e to the cosine q times the sine of q. Alright, so now we have di dq expressed as a function of q. Now if we want to find the derivative when, don't forget we were asked to find derivative when q equals negative pi radians. So now we got to substitute that number in, and that's going to be di dq at negative pi. So that's going to be negative e to the cosine negative pi radians times the sine of negative pi radians. Okay. Now, let me see how well I remember my unit circle here. So if you got your unit circle, then pi radians is right there. So that means that cosine, or negative pi is also there. So that means cosine of negative pi is 0. So this part becomes 0, and this part becomes 1. E to the 0 power is 1. Sine, and that's also multiplied again by 1. And so what we get is negative 1. Wow, didn't that work out nicely? It's like somebody planned this. Okay, so if you have a function f of t equal to e to the t to the 4th power, then your inner function is t to the 4th power, your outer function is e, and so to solve the to find the derivative, we again use the chain rule. So f prime of t, otherwise known as the derivative of f with respect to t, is the same thing as, well, when you're taking a derivative of e to the whatever, that doesn't change. So that's going to be the derivative of the outer function. And then the derivative of the inner function is t to the 4th. That's a really simple power rule. So that's just 4t cubed. Clean this up a little bit, and you get 4t cubed times e to the t to the 4th. All right, and that's your answer. All right, now this is getting a little weird because we got our inner function is a trig function and our outer function is a natural log function. But it's really no different from anything we've done before. It's just the functions are a little stranger. This combined function is called h of p. We would want to find dh dp. So dh dp is going to be the derivative of the outer function, so that's the natural log function. Derivative of a natural log is just the reciprocal of, or derivative of natural log of x is the reciprocal of x. So derivative of the natural log of cosine p is just cosine of p. That's multiplied by the derivative of the inner function. Inner function is cosine p. Derivative of cosine is negative sine of p. And clean this up a little bit. You get negative sine. Wow, this is getting, my handwriting is getting really ugly here. All right, negative sine of p over cosine of p, which is negative tangent of p. Kind of an unusual result, but it works with everything we've done. Okay, last example in this video is going to be like the last example in the last video. This is not just a function inside of a function. This is a function inside of a function inside of a function. And in fact, let's make it even more fun. Let's add in something else. Okay, so we've got two functions added together. That's the 3t and the e to the whatever. The 3t should be easy to take the derivative of, but the e to the whatever part, you have the inner function of the 6t, you have the middle function, which is the 4 times sine of of the inner function, and then you have the outermost function, which is e with an exponent of the middle function of the inner function. All right, let's go ahead and take the derivative of this. We're going to have to take this kind of one step at a time here. All right, so, oh, and on top of that, we're not just asked to take the derivative, we're asked to find the value of the derivative when you've got pi over 6 radians. Alright, so we got to take the derivative first, and then we got to throw pi over 6 radians into that value, evaluate, and compute from there. Alrighty, so we got dl dt, well actually I called it L prime. So L prime is going to be the derivative with respect to t of the quantity e to the 4 sine quantity 6t plus 3t. Okay, since we have this addition sign here, we can separate the two we can separate the derivative to be the derivative of the stuff before the plus sign plus the derivative of the stuff after the plus sign. Okay, in other words, we can distribute the d dt around the plus sign. So this becomes derivative of e to the 4 sine 6t plus the derivative of 3t. Well, the derivative of 3t is easy. It's just apply the power rule. 3t is 3t to the first power, and so this becomes just a plus 3. Actually, let me, yeah, okay, so this part, whoops. So this part just becomes plus 3. This other stuff, on the other hand, is going to get a little complicated, because like I said earlier, we got the inner function, that's the 6t, we got the intermediate function, which is the 4 sine times the sine of the inner function, and then we got the outermost function, which is e raised to the power of the middle function. And so to apply the chain rule to all of this, we have to do it basically 3 times. Outermost function, intermediate function, innermost function. Got to work our way inward. So this is going to be e to the 4 sine 6t. Remember, derivative of e to the x is just e to the x, so we just consider the e part, and then we just consider the 4 sine whatever, so this is going to be times a quantity 4, alright, derivative of sine is cosine, and leave the inner function alone. Last part is to take the derivative of the inner function. Inner function is 6t, derivative of 6t is 6. Okay, so now all we have to do is clean things up and then substitute in the pi over 6, and so that's going to be, let me see, this is going to be 24 times the cosine, let's put the e function first, e to the 4 sine quantity 6t times the cosine of 6t plus 3. Alright, so that's our derivative, but we're not done yet. We're asked to find the derivative when t is equal to pi over 6 radians. So, let's try gray ink. Alright, That's a not particularly straight line. Alright, so now we got to substitute in pi over 6 radians here, so we get L prime of the quantity pi over 6 is going to equal 24 times e to the 4 times the sine of 6 times pi over 6 times the cosine of 6 times pi over 6 all of that plus 3. Alright, so this part becomes pi. Actually, let me just rewrite this. So that part there becomes pi, that part there becomes pi. So this is equal to 24 times e to the 4 sine pi cosine pi plus 3. Alright, let's see. Sine of pi is, again, unit circle. Pi is right there, so that's got a vertical coordinate of 0. So this part here is 0. Cosine of pi is 1. So we got 24 times e to the, let's see, 4 times 0 is, 0, times 1 plus 3, and so this is going to be 27. Alright, that's it. Next video is going to have some practice problems for you to do on your own, and the answers to those practice problems will be in a video. Sorry, as I was reviewing this video, I noticed a few problems. Let's start with this slide since you just finished taking a look at it. Most of these problems arise from my inability to read a unit circle properly. So while sine of, looking up here in this area, while sine of pi really is 0, cosine of pi is not 1. It's -1. And so that should be -1. And so this is not 27. Let's clean this up. So this is going to be 24 times 1 times -1, which is -24. The plus 3 sticks around, and so this is actually -21. Okay, going back a few slides as well. Oh yeah, very first problem. I distributed the x to the x to make x squared, but I forgot to distribute it also to the 12, so this really should be 12 over x squared minus 12x. And in this problem, problem 7, again, I seem to be unable to read a unit circle. So cosine of -pi is not 0. Alright, so at this stage, we're having some problems. Or, not we. I'm having some problems. So if we, oh man, that obliterated a lot. cosine of negative pi is, again, negative 1. So if we fix this a little bit, this becomes negative 1, and sine of negative pi is not 1, it's 0. So really, what we should get is not negative 1 times 1, it should be whatever all of this is, it's going to be multiplied by 0, and so really our answer should just be 0. And this is an interesting implication, an interesting result, because if the derivative is 0, that means that you have your tangent is a flat line. In other words, your tangent is horizontal. And something that we'll get into later is at points where your tangents are horizontal, like right here and right here. I'm not saying that this gray drawing is a picture of I of Q, but in general, your tangents get horizontal when you hit these peaks and troughs. But that's for another lesson. All right. Sorry about the mistakes. Hope this is making sense.